Hi everyone, my name's Jeff Dean and I'm Math Dad. I'm here to help you help your kids understand math. And today we're talking about equivalent fractions. That's when we have two fractions that are written different ways, but they represent the same amount of the whole. For example, 1/2 and 2/4. Most of us know that 1/2 and 2/4 represent the same amount. But how do we help our kids understand why other than just memorizing? Take a look.
Creating equivalent fractions is as simple as changing the way your shaded piece is partitioned. Currently, you can see I have 1/2 because I have one of the two equal sized pieces shaded. Each of these pieces is a size 1/2. Now, if I wanted to partition this differently, I could do something as simple as just draw a horizontal line straight through the middle like this. And now you can see the shaded piece has not changed, but instead of being partitioned into two equal sized pieces, it's now partitioned into four equal sized pieces. So I can say that I now have two shaded parts of the four equal sized pieces. Now, I could just keep partitioning like this over and over and over as long as I maintain the fact that I keep equal sized pieces. For example, I could come right through the middle again, just like this. And now, instead of having four equal sized pieces, I have 8 equal sized pieces. And how many of those equal sized pieces are shaded? 4 of them. That's why 1/2 and 2/4 and 4/8 are called equivalent fractions. Now, I could really get creative here and partition this lots of different ways. For example, I could come across here, but instead of cutting it in half, I can cut each one of these into 3 equal sized pieces. And now, again, the shaded part hasn't changed. And I now have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24 equal sized pieces. And how many of them are shaded? Well, there's 6 here and 6 here. There are 12 of them that are shaded. So as long as I keep making partition cuts that continue to equally partition my whole, I maintain what are called equivalent fractions.
Once we've worked with our kids to help them understand how we can partition fractions over and over and over again to generate other fractions that are equivalent, they're ready to start working on specific equivalent fractions. For example, suppose I have a fraction and I want to write an equivalent fraction by changing the denominator. In other words, I want to change the size of the equal sized pieces. What would I do in that case?
Suppose I start with 3/4. And I want to write an equivalent fraction, but instead of having a denominator of 4, I want a denominator of 8. And in order to do that, we need to remember, what does this 4 mean? It means that I have 4 equal sized pieces that are cutting up this whole. In other words, each of these pieces is 1/4. But I want this to be an 1/8, which means I need to have 8 equal sized pieces instead of 4. And the quickest way of doing that is to partition this right down the middle. Now you can see I have 8 equal sized pieces, and each of these is now 1/8. So how much is shaded? Well, I have 1, 2, 3, 4, 5, 6 of those 1/8 size pieces shaded, which gives me 6 of those 1/8, or 6/8. And because I didn't change how much of the whole was shaded, I just changed how it was partitioned, I know that 3/4 is equal to 6/8.
As you know, fractions don't just have denominators, they also have numerators. And we can do a similar process if we want to change the numerators instead. In other words, we now want to change how many equal sized pieces that we have. Take a look at how we would do that.
So in this example, you can see that I'm starting with the fraction 2/3. I have 2 of these 3 equal sized pieces shaded in. But I want an equivalent fraction. And what I want to do is I want to change the number of equal sized pieces from a 2 to an 8. So how do I do that? Well, if I draw a horizontal line here, I now have 4 equal sized pieces that are shaded, but I said I wanted 8. So I need to do this one more time. And you can see I haven't changed how much of this rectangle is shaded. All I've done is change the partitioning. I now have 8 equal sized pieces. And those 8 equal sized pieces are each a size 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Each one of them is 1/12 of the original rectangle. So 2/3 is equal to 8/12.
Now, these models, they're just a starting point. Eventually, we want to help our kids get to the point where they're not having to draw pictures every single time, but they can actually use multiplication to help them find equivalent fractions. So take a look at how we can start to transition them from models to using multiplication so that the process becomes a little quicker.
So let's go back to our 2 original problems here. When we started with 3/4 and wanted to write an equivalent fraction that had a denominator of 8, what we did was we drew a horizontal line right through the middle here, so I now have 8 equal sized pieces. Well, 8 gave me twice as many pieces as 4, so in a sense, all I did was multiply by 2. And I went from 3 equal sized pieces to 6 equal sized pieces, so I multiplied the 3 by 2 also, and that's how I got 6/8. One of the reasons why this works is because this 2/2 is just equal to 1. And we know that anytime you multiply by 1, you get the exact same number right back. So that's how I know that 3/4 and 6/8 are the same, or equivalent fractions. When we look at 2/3, we did the same thing, but this time we wanted our numerator to be 8. In order to have a numerator that's 8, we had to have 8 equal sized pieces that are shaded. So we divided it like so. And that gave us 8 equal sized pieces. And that is 4 times as large as 2. And we went from 3 equal sized pieces here to 12 equal sized pieces, which is 4 times larger than 3. And that's how we ended up with 8/12. And again, since 4/4 is the same as 1, we really just multiplied by 1. That's how I know that 2/3 is equal to 8/12. If I was to do this all without modeling, it would look something like this. Suppose I had 3/5, and I wanted to rewrite it so that the numerator was now 9. If I think about what do I multiply by 3 to get 9, well, 3. 3 times 3 is 9. So I also have to multiply the denominator by 3. 5 times 3 is 15. And since what I multiplied by is just equal to 1, I know that 3/5 is the same as 9/15.
Well, that's it. That's equivalent fractions. And once your kids master finding equivalent fractions, they have got the key to so much with fractions. It's the key to something like finding common denominators. And once you know how to find common denominators, you can add and subtract fractions without too much struggle. So, I hope that we take the time, we help our kids understand the models, we then transition them from the models to using multiplication so they can find any equivalent fraction that they want. That's it. My name's Jeff Dean, and I'm Math Dad.